Hey everyone, welcome back to this special demo on SQL Numeric Functions, where I'll be discussing the mathematical operations using PostgreSQL. So mathematical functions are very crucial to learn in SQL because it allows you to implement different mathematical concepts using queries. So SQL has various mathematical functions that can allow you to perform data and engineering calculations. And so some of these commonly used and most significant mathematical functions in SQL that have daily use I'm going to focus on them today in this demo, and I'm going to explain each one of these to you to explain what the logic are for these functions and what they try to achieve, and also show you how you can use SQL basic functions to perform them. So without any further ado, let's get to it. I'm going to start with ABS. So ABS is the absolute function. What it does is going to extract the absolute value of a number for you. So let's say if you have a number that's, let's say, -100, right? This number is in a negative mode, in a negative state, because it has the minus sign, right? So it's a negative number. So regardless of the sign, if you want to ignore the sign and actually get the absolute value, right? Then you're going to perform what we call an absolute function. An absolute function will allow you to get this. So, and the way we start for functions, same way we use select queries for everything else, especially for the arithmetic or other numeric functions. So for mathematical function, we do the same thing. We're going to start with select, and then we're going to pass our function, and then we're going to pass our value inside the parentheses. So we're going to go ahead and run this, and you're going to see as a result we're going to get 100. So again, 100 is the absolute value um, for the -100 or negative integer that we have here. Same thing, if you want to use, if you can also perform the absolute function on your entire multiple values in a column, right? So you want to get the absolute values for all these numbers here. And before I start talk about the column here, this data set, the function practice is just a dummy fabricated with fabricated values plugged in there. I put together just for the sake of this demonstration, and I also intentionally created this column where I inserted some values here with negative signs, right? Negative integers, so that I can demo you how you can change them when you want to perform a absolute function on a column. So let's go ahead and perform this on X metrics, right? And it's going to be the same drill ABS, except that in here, for instead of passing the numeric value, you're going to pass the name of the of the column, right? So X metrics are a column, and then we're going to specify the table name, which is the functional practice, which is in short func practice table. And we're going to go ahead and perform it, and you're going to see we get all of the um, absolute values for those integers. So if I were to bring the rest of these columns here to so that I can show and compare them here, I'm going to bring the ID, I'm going to bring the live average column, I'm going to bring the country column, the region column, and I'm going to bring the X metrics column. And then I'm also going to put this under the alias X metrics absolute extract. So let's go ahead and run this, and you're going to see that now we have two columns where one is the one is the X metrics column with some negative numbers here, and then the other one is all of the absolute numbers converted, transformed from this column. So why do we use absolute values? You will be surprised. You will make use of it a lot. I've used it a lot, especially the last time I remember is I use it for variance. When you want to determine the variance or differences from an average, right, of like multiple data points, then you at some point you will need to get the absolute values or differences. In that case, you will need to perform an absolute mathematical function to get the absolute value. So it has use in algebra, in mathematics, in statistics, in all walks of scientific disciplines. So just as long as you know that there's a function, there's a functionality within SQL, just like other tools that allow you to easily convert your negative numbers or numbers at regard, whatever state they are in, to an absolute state. Now let's go to the second one. Without any further ado, talk about the round. And so round, as you know from the name, is easy as it sounds. So rounding is you use it is a function that you want to round a number to a specified number of decimal places. So there are rules. So for this for the round, when you pass it in the parentheses. So for example, when you say round and you put a, let's say, a number 5.6, and then I'm going to round another one, round 55.3. You're going to see when I run these two functions, for the exact value numbers, round, open parentheses, close parentheses, uses the round half away from zero or round toward nearest rule. What it does is a value with a fractional part of uh, uh, dot 5 or 0.5 or greater is rounded to the next integer if positive, or down to the next integer if it's negative. So in other words, it's rounded away from the zero. A value with a fractional part less than 0.5 is rounded down to the next integer if positive, or up to the next integer if negative. So 5.6 is going to be rounded to the next integer because it's greater than 0.5. 0.6 is greater than 0.5, right? Or 0.5 or above. It's 0.5 or greater. So when you run this one, you're going to see we're going to get 56. Because why? Because our decimal is equal to or greater than 0.5. Now, if we were to run this one, because this one actually is less than 0.5, right? If so in this case, is going to round to down to the next integer, meaning to the 55. So this one rounds up toward the next integer to go to 55 to 56. This one rounds down to the next integer, which is 55, if it makes sense. So you can also pass additional parameter here. For example, if you have multiple decimals, right? Because the idea here is for you to be able to specify number of decimal places. So let's say if you have 66 here, right? And you want to round it up to one decimal places, right? So you're gonna get that rule will still apply, but the only thing is that you're gonna get the one decimal rounding happens. So it's 55.7 because the second decimal here gave up its value to this decimal, because we rounded to one decimal places. This one is now 50. This one is now 7, and this one is lost. Same thing with 3. If we let's say if we have 34 and you want to round it to one decimal places, you're going to see that it's going to retain the 3. It's not going to add any value from 4 to 3. Why? Because it fails it fails the rule of being at 0.5 or greater. Since this one is lower than this one is smaller than 0.5, the 55.34 is going to be 55.3 when it's rounded to one decimal places, so it's 55.3. It did not work because of what I just explained to you. Now let's say if we had three decimal places, 3 point numbers, let's say 66.5, right? And then you are going to go ahead and put 2 here, which means which you're saying pretty much round it to 2 decimal places this number for me. You're going to see as a result, you're going to get 55.67. Why? Because now this time we're rounding it to the second to 2 decimal places. This time this number, again, this one is intact, but this number is affected, and the reason is that the last number is 5, and it complies with the rule of being 5.5 or greater. Therefore, it's now rounded to 67. Same thing. Now, if we have 3 point, let's say 43 here, and do the same thing, round it to the 2 decimal places, you're going to see that we're going to get the same 3.4. Because why? Because the last value here is lower than 0.5, so it did not round to any number higher than 4, because it's 3 here. We have 3 here. So again, if you use a round without passing the second parameter here, the second argument here, which you specify the number of decimals, then SQL is going to treat it as a 0. So then it's not going to give you any decimal place, just going to give you the entire integer as we just showed you, as I showed you at the beginning. So let's do this on a column. We can perform this on a column to get the rounded numbers, and I have some numbers here that I like to round them. So let's say we want to round everything from live average. Scroll this down, live average. Select, I always forget to pass the function. And so if we don't pass the number of decimals, then it's going to, as I said, is going to consider it as 0. So all these numbers should now change to, oh, I forgot to put the name of the table. So all these numbers now should be rounded to to their relevant uh, 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 up or lower integers. There you go. As you can see now, these honest to better explain, let me just go ahead and put these columns next to them, and then call this as live average rounded. Let's go ahead and run this again. And there you go. You can see that the live average are now rounded. So 50.56 for is now rounded to 51. Why? Because first of all, we don't have decimal places here. All of them are integer. Why? Because in the value we did not specify how many decimal places we would like to round them to. We did not specify. When we don't specify the second parameter, we're actually telling SQL to consider it as 0 decimals. So when you have 0 decimals, that means there's no point. It's only one. It's just integer. There's no decimal places after the actual number. So 50.56 is now rounded to 51, and the law and the rule of 0.5 or greater applies here. So because 56 is greater than is equal to or greater than 0.5 or 0.50, so now it's rounded to 51. Now here 63.65 is also 64 because it's 65, and 58.35 Brazil is 58 because it's 35. It did not pass the rule of 0.5 or greater. So now you have an idea how rounding works. Hopefully you know now what rounding is. Just as a refresher, I'm sure you know what rounding is, and you know what the decimal places are in a number. But remember, if you I keep saying integers and I keep saying decimal places. If a number has decimal places, that number is not an integer anymore. So this is an integer now, because integer does not have decimal places, does not have points. So 51.5 is not is a decimal number, is definitely a floating numeric data. But it's definitely not an integer, because integers, they don't have decimals. Integers are standalone numbers, like pretty much distinct discrete numbers that do not take any decimal places or points. So that's why just want to clarify this, because I keep saying integers with decimals. That's not what I meant to say. So while this is decimals numbers, this is not decimal number. These are actually integer numbers. And if we don't specify a decimal places for a number that we pass, then we're gonna get, if we put 0, or we do not specify, which in this case translates to 0, then we're going to get an integer as a result. All right, let's now move to the third one, which is the square root. So square root also has a lot of applicability in your daily activities, I'm sure. Also in the statistics, you'll make use of it. So I'm not going to get into details of what square roots are. I'm sure you know them. Square root is here is pretty much just like everything else. You can pass square root function. So let's say you want to get the square root of, let's say 25, and you run it. You're going to see that it's going to give you a 5. Square root of 25 is 5. You can also perform a square root on multiple values. In this case, let's say we want to perform a square root on all these live average numbers. And so we're going to say select square root, live average, and then from this table func practice, and run it. And there you go. These are the square root of the live average for all of them. Uh, that was the square root, and square root and power kind of goes hand in hand. because one reflects the other, mirrors the other. So let's say if the square root of 25 is going to be 5, then the 5 to the power of 2 is going to be 25. So let's talk about that. Let's say now we would like to perform power. Just put the title here, power, and select power, and then put 5. So you're going to see, oops, sorry, I did not pass the second parameter here, which is going to be 5 to the power of 2, right? That's 25. So it really depends on what you assign uh, to the y variable, because when you're doing a power xy, you're pretty much asking for value of x raised to the power of y. So we raised the 5 here to the power of 2. So when you raise 5 to the power of 2, you're getting 25, because 5 times by 5 is 25. But then if you do the square root of 25, you're going to get 5. So that want to make sure that I know it's a refresher, power and square root. These are very, very, very basic mathematical concepts. So you can also extract the power function. Let me go back, bring the table up here of the entire column. Let's say you want to get the power. You want to raise, let's say, all of these values to the power of, let's say, 2. Let's say select power, and then you specify like average, and you raise them to the power of 2. You're going to see as a result all of these numbers live out. I did not specify this. I keep making this mistake. That's a problem between performing function on a value standalone, or performing a function on a column and then calling it from a table. There you go. So these are the values returned when we raise the live averages to the power of 2 here. So remember that some functionalities will require you to pass one parameter, and some functionality will require you to pass two parameters. So keep that in mind. Look at the structure, the syntax of each function, depending on what tool you're using, and then pass your values based on that. And something else that from this point onward, I'm going to, because I feel like I'll be going above my time bound. I'm going to not perform these functions on the table columns. I'm just going to explain what these mathematical concepts are, and then just run a simple query just to get the result of it. And then you can use these the examples I showed to apply them on the table to to perform to perform it to perform it on a table, calling in a column from a table. But I'll just be performing it on one value from this point onward. Uh, However, there are some functions that do not apply to columns. You may have to like pass the argument there as a value, but most of them can also work with specific arrays and columns from the tables, or multiple columns from the tables. So this was square root, and this was power, which I just explained both of them. Now let's go to the other one, the ceiling. Ceiling and flooring, these are also very basic concepts. Ceiling returns the smallest integer value, not less than x. So let's say if you say select ceiling, uh, let's say if you put 1.23, you're gonna get 1 1. Why? If you're gonna get 2, why? Because the flooring gives you the other way around. Sorry. So ceiling is going to give you 2, because why? It's returning the smallest integer value, not less than x. So it's not going to be less than x. X is 1. So the smallest integer is not going to be less than x. Is going to be 2. And same thing with flooring, which is the like the opposite of ceiling. You're gonna get the largest integer value that's not greater than the x. So you're going to say floor, and then let's say you specify and you put let's say 1.23. You're going to see now that you're going to get the flooring. You're going to get the largest integer value not greater than x. So this one is going to be not less than x, right? X is 1.23, and this one is going to be not greater than x, meaning that 1.23. So that's going to be 1. So ceiling and floor, while ceiling gives you again the value that's not greater than x, is going to be then the flooring is going to give you the value that's not that's not going to be greater than x, and ceiling is going to give you the value that's not going to be less than x. So they have usability too. I've used them before, but when you're using rounding or when you're using any type of decimal places assignment, you will not make use of ceiling and flooring. But ceiling and flooring is just an easy way for you to return like smallest and largest integer from values based on based on the fact if they're less than x, the value that you're giving, or if they're greater than the value that you're giving. So the next one is going to be pi. And talking about pi, this was one of the most complex thing, the easiest thing, and also most complex thing you probably learned in like middle school. Pies are, if you remember pi, we talk about pies in the context of like circles and distance in circles. So it's the value of pi is pretty much the ratio of the circumference of a circle to its diameter. So and it's approximately the number of pi, as far as I remember, it's 3.14 or 3.14, something like that. So in other words, in a circle, if you divide the circumference, right, and circumference is, if you remember, it's the total distance around the circle. So it's the distance of that circle. If you make a circle around, if you make draw a distance around the circle, then that is that's the circumference. So if you divide the circumference by the diameter of the circumference, then you'll get the pi. So the pi is the ratio of circumference of a circle to its diameter. So to get the pi, there's a function to get the pi, and I just wanted to make sure to include here as well. You pretty much enter the pi, and when you don't pass any value, you're gonna get the actual standard value for the pi, which is 3.14159. Yep, there you go. This is the pi value that I can remember. So again, the pi function returns the value of pi, and so the default number of pi, which I just showed, if you don't pass a value, is going to be shown for you, which is 3.141.59. The next one is the cotangent. So the cotangent function returns the cotangent value for you. Let's say you want to get the cotangent of let's say you want to get the cotangent of 10, and you're going to pass the value, and you're going to run the argument, and you get the result here. The next one is going to be the cosine and sine. These are the two things that you probably need, especially when you're doing more advanced calculation. Also has some algebraic uses. So to get the cosine, again, you're going to run the same function as I just did for everything else. Select cosine, and then just run and then pass the parameter. For example, if you put 1, you're going to get the cosine of 1. If you remember, it's a very famous thing. Cosine and sine, those are the two things that you probably remember from middle school as well. Probably something that you studied in high school. So this next one is sine. Oops, I forgot to put this. Um, then is sine. So to get the sine, pretty much the same way that you pass that you apply any function, which is select name of the function and then the argument. So sine is going to be the same way. You're going to let's say assign let's say 0, sine of 0, or the sine of 1 is going to be 0, or if you say the sine of 1, it's going to give you they're not specified, 0.8114. So let's see the next one. I'm going to go a little bit fast because I think I'm running out of time. It's going to be degrees. Degrees is also something that has to do needs to be discussed in the topic of radians, and how we can convert radians to degrees and degrees to radians. So degrees is pretty much converting a radian to you into degrees. So let's say if you want to change, for example, uh, if you want to get the degrees of let's say a radian that's, let's say 180 degrees, or let's say 90 degrees, then you're gonna get the degree for the radian of 90 uh, is going to be, oops, sorry, I got the wrong one. So that's too long. The degree of the radian, for example, is going to be 3.14159, or let's say I just put 3, and I run this. You're going to get 1.71, sorry, 171. And I think the degree of a pi is 380, and its radian is 3.14141415. Let me check. The pi is, yeah, 3 point, yeah, let me just get a copy of this and then run 3 point, and then put this in the degree so we can see what degree this has while this for this radian that we extracted from the pi value. There you go, 180. So a pi is 180 degrees, right? And a pi is also equal to 3.14159 radian. So the degree function actually converts a radian value to a degree value. So let's say if we have 1 radian value, then you're probably going to get something around maybe 60, or maybe a little bit below that. There you go, 57. So that's the degree of 1 radian. And you can also say, I think you can also pass the, let me see if this will work. Let me see if I can pass the pi function here uh, and say, give me the degree of the radian that comes from the pi. I think I made a mistake here. The pi has to be pi. Yep. So yeah, so 1 parentheses for the pi and then 1 for the met. Yeah, this should do it. Let me see. There you go, 180. So the degree for a pi is 180 degree. For a pi is 180. And so that was a degree. Let's talk about radian. Sorry, I'm just trying as fast as I can. The radian pretty much is like the opposite. You're converting degrees to radians. So let's say if you want to change the degree to, let's say 180 to a radian, well, that should give you a 3.1415, which is 1 pi. So let's say if you want to change a degree of, let's say 150 degrees to a radian, then you're going to get a number. It's going to be around 2.6, yeah, 2.61. So there you go. So whatever number that you get from the degrees, from the radians converted to a degree, is the number you're going to get for let's say if you put 1.5 here, get the radian for 1.5, which is 885. Copy this and then put 85 to get the radian for this degree. You're gonna get that same number, 1.5. So 1.5 here, 1.5 there. We tested it and it's correct function. Is going to be the exponential logarithm, or EXP. So what it does, it returns the value of e, which is the base of natural logarithm raised to the power of x. So the EXP function returns e raised to the power of a specific number. So when you return e raised to the power of a specific number, you're using a constant that's 2.7 or something, which is the base of the natural logarithm. So let's say if you want to get the XP for let's say the number 5, right? You are raising that constant to the power of the specific number which you just passed here. And the next one is going to be log, and it's pretty much the log is used to calculate uh, the logarithm of a number. So if we call with 1 parameter, it will return the natural logarithm of a specific number. So it accepts 2 parameters as to where the 1 parameter holds a number which is greater than 0 base. Is optional if you want to keep 1 parameter or 2 parameter. But if we were to use with 1 parameter, right, we're going to say, let's say, give me the log of, let's say, and 1050. I'm just coming up with these random numbers, and we're gonna get 3. So that's the without passing 2 parameters, the second parameter, right? And so the next one is going to be the log of 10, which is very obvious. The log of 10 returns the base 10 logarithm of the x or specified number. So the log 10 function could be used to calculate the natural logarithm to base 10 of a specific number. So we're just using base 10 here now. So if we say log 10 and we say give me the base 10, and we pass the value, let's say 5, we're getting we're pretty much getting the base 10 of our x, which is 5 here, the log base 10. So, and the next one is going to be the MOD. So the MOD is the modulo operation, which we can use to return the remainder of x divided by y. So it returns null if x or y is null, but it works on values that have a fractional part, and also return the exact remainder after division. So let's say if you remember from division, let me get a calculator. Actually, that's a good idea. Let me get a calculator here. And so if you remember, when we perform division, for example, if we perform division on an odd number, for example, if we say 13 divided by 2, right? We're gonna get 6.5, right? But if we were to do this in on paper, right, and if we say 13 divided by 2, the 13 divided by 2 will be 6. And if we do 6, we have one number left. It's a remainder, right? And so that one number, before we convert it into a decimal point to get 6.5, that one number is the MOD. It's the remainder of x when it's divided by y. So for example, in this case, if we say, let's say if we say 13, or let's say not maybe, yeah, 5 divided by, let's say 2, right? Once 5 is divided by 2, that will be 2, 2.5, right? So, but then if we want to not use a decimal and we use the remainder is going to be 1, because it's going to be 4 divided by 2 is 2, and then we have one number left. So that number is a remainder that we can use MOD to extract. One second. I hope I didn't get too confused with this one. And next one is the tangent, and the tangent is, I'm not going to get into the explanation of the content of the tangent. So tangents pretty much gives you the value of a given of a given number in tangent, which is given in radians. So you can use the same thing, tangent, and then pass a number. For example, if you want to get the tangent of a pi, let's say, which is or let's if we can either do pass the pi, or we can also pass the number. Let me see if pi will work. There you go. A tangent of pi is minus 1.2. So that's the tangent radians. So remember that in radians we have different measures that we can use. Tangent is one of those that we can get the value of in radian measures. Um, let's say the next one is going to be sine. Sine is something that you probably have used more like in scientific notations. So pretty much it's used to return the sign of the given number. So it returns to 1 if the number is positive. If the number is negative, then it's going to give you -1, and if the number is 0, then it's going to give you 0. Simple as that. So it's going to go between ones and -1 and 0 in between. So it goes from -1 to 0 to 1. So let's say if you want to do sine of, let's say, for example, a number that has, say, 5, you're going to get a sine of 1 for it. Now, if this number was -5, then you're going to get a sign of -1 for it. And if you want to get a number of 0, then you're going to run a 0, and you're going to get a number of 0. You know how they say computer science is a science of zeros and ones. There you go. So that's the good start point. Think about it. And then the last one is the random number generation. I'm running out of time, so I'm gonna keep that, not only because I'm running out of time, also because this is such an important topic. I was hoping I can save some time to talk about this, the random number generation, in more details. But I promise I'm going to have a separate video where I'll review in much details what the random numbers are and how we can generate them using sequels. I think this is it. If you got a value, I know this video was long and boring, but if you still think you got value out of the tutorial, please do not forget to like and subscribe my channel as always. Thank you so much. Until next one.